Good day, everyone. We are the group 2. The group members are Joby De Jesus, Jinyan Giao, Moliaz Nazareno, and yours truly. So our topic is all about measures of angles and segments. And then the learning objectives of the topic are the following. First, recognize important terms which is a foundation in understanding the angles and segments. Second, articulate the difference between angles and segments through elaboration, properties, and also illustration. And lastly, understand the angle and segment postulates through illustration examples.
First, allow me to introduce important concepts or terms. So we have this line segment. So it is a part of a line that contains every point on the line between its endpoints. And we have this illustration below. And ray on the other hand is a portion of the line consisting of an endpoint and all points which are on one side of that endpoint. And we have also an illustration alongside. And midpoint is the point that divides the segment into two congruent segments. And we have also illustration. And bisector of a segment is a line, segment, ray, or plane that intersects the segments at its midpoint. Now, introducing to you the angle. So, what is angle? It is formed by two rays intersecting at the point called the vertex of the angle. So, the two rays are called the sides of the angle. So, the amount of the opening of the two sides determines the measures of the angle. So, meaning to say, so whatever the opening, so if it is narrow or wide open, so there is a corresponding measures. So we have this illustration. So as you can observe, so the unit measure of angle is degrees. So and the instrument used to measure the angle is a protractor. This picture of protractor, and we have this kanang red and black orientation. So red indicates the inner scale or the direction is in counterclockwise. So from right to left, and we have also the black orientation which is indicates outer scale or the clockwise direction. So from left to right. So the angle can be named using letter assigned to the vertex, and we have this illustration. So in naming the angle, so let's have we have example. For example, we have this angle MAB, angle CAM, angle BAN. So however, if there are several angles to the same vertex, we use the three letters in naming the angle. So for example, angle CAB. So in naming the angle, so we have this angle CAM plus angle MAB. So it's equals to angle CAB and so forth. So we have different types of angles or different orientation of angles. So first we have this acute angle which measures less than 90 degrees. And we have also right angle that measures exactly 90 degrees. And we have also obtuse angle that is greater than 90 degrees and of course less than 180 degrees. So we have also straight line which measures exactly 180 degrees. And we have also reflex angle that measures greater than 180 degrees. And also, and of course, less than 360 degrees. And we have also the full angle which is exact. It measures exactly 360 degrees. So, introducing the protractor postulate that states that the measures of angle AOB is equals to the absolute value of the position of ray OA on the protractor and the position of ray OB on the protractor. So we have this illustration below. So we have this measure angle AOB that runs from clockwise direction, from left to right. So we have value of our ray OA which is 70 degrees minus the value of our ray OB which is 150 degrees. So resulted to the absolute value of negative 80 degrees which is 20 degrees. So measures angle, we have also measures angle AOB that runs from counterclockwise direction. So we have this value of our OA which is 30 degrees minus the value of our ray OB which is 150 degrees. So calculate the difference. It results to the absolute value of negative 80 degrees which is 80 degrees. So another important concept is angle addition postulate. So it states that if D is in the interior of ABC, then angle ABD plus angle CBD is equals to angle ABC. So to further understand, so we assign a value. So angle ABD we have 60 degrees, and we have also as angle CBD which is 40 degrees. So we have to calculate the sum, resulting to 100 degrees, which is also correspond to our angle ABC. So muna siya ang angle addition postulate. And for our next topic, so let's have Jenny and Kiyaw to discuss to you about the measures of segments and also geometry issues.
Measures of segments. One of the most important words in geometry is congruent. So this term refers to geometric objects that have exactly the same size and shape. Two segments are congruent if they have the same length. So a segment is a set of points consisting of 2 points of the line called the endpoints, and all of the points of the line between the endpoints. It is commonly used to represent the length, height, or width of a certain object and the distance between two objects. Notation notes. When two things are congruent, we use the symbol congruence. For example, if line segment AB is congruent to line segment CD, then we would write line segment AB is congruent to line segment CD. When we draw congruent segments, we use tick marks to show that two segments are congruent. 3. If there are multiple pairs of congruent segments which are not congruent to each other in the same picture, use 2 tick marks for the second set of congruent segments, 3 for the third set, and so on. See the 2 following illustrations. So if 2 angles are congruent, then their angle measures are equal. If the angle measures are equal, then the 2 angles are congruent. So the same number of mark shows congruent angles.
Properties of congruence. Reflexive property. When a relation has a reflexive property, it means that the relation is always true between a thing and itself. So, if segment AB is congruent to segment AB, or angle B is congruent to segment B. Next property is symmetric property of congruence. When a relation has a symmetric property, it means that the relation is true between two things. It is true either order. So, if segment AB is congruent to segment CD, then CD is congruent to segment AB. Or if angle ABC is congruent to angle DAF, then angle DAF is congruent to angle ABC. Next property is transitive property. So when a relation has a transitive property, then two things that relate to a common middle thing also relate to each other. So if segment AB is congruent to segment CD and segment CD is congruent to segment AF, then segment AB is congruent to segment AF. Or if angle ABC is congruent to angle DAF and angle DAF is congruent to angle GHI, then angle ABC is congruent to angle GHI. Segment addition postulate. Segment addition postulate states that if we have a line segment AC and a point B within it, the sum of the length of the segment AB and BC will give the total length of AC. So how do we use the segment addition postulate? Given a line segment AC and a point B in between, if we know the length of AB and BC, we can find AC using the equation AC equals AB plus BC. For example, if AB equals 5 and BC equals 10, what is AC? If the points A, B, C are on the same line and B lies in between A and C, then AC is the sum of AB and BC. So we'd get AC equals 50. On the other hand, if A lies in between B and C, then AC is the difference BC minus AB, which gives us AC equals 5. If the points A, B, C are not collinear, then AC length will depend on the angle that's between AB and BC. So let's have, for example, finding the length of segments. So we have DE equals negative 5 minus 3 equals 8. Negative 5 is the value of D and positive 3 is the value of E. So negative 5 minus 3 equals 8. Another example using segment addition postulate. So we have here the MN plus NP equals MP. So our MN is 5x minus 4 and NP is 2x plus 14 and MP is 80. So 5x plus 2x is 7x and negative 4 plus 14, so we have plus 10, positive 10 equals the NP, which is 80. So to get the value of x, we can conclude that our x is 10. So substitute the value. So we have 7 times 10, 70 plus 10, so 80 equals 80. So that's all. Thank you and God bless.